So thanks once again for coming tonight. So just a few quick announcements before we get started. In a couple of weeks we have another meetup. You heard the Spark, Kafka, and Vodka meetup. It's going to be at Team One Advertising in Marina Del Rey. So please feel free to attend that. 3 days later, on December 10th, we are doing the annual LA Holiday meetup party. So it's pure networking event. So by several meetup groups, including this and as well as the PHP, MySQL, Mongo, data science, and several other user groups will be attending. So that's completely free. Please go to the website and sign up for that. On the logistics, just at the end of this, if you don't mind, if you could just take the chairs and put it around the tables out there, really helpful to the organizer out here. I want to thank Aaron for helping me host this event. So he's the my contact at Factual, and he's the one who's helping me set this event up out here. Also, you can thank him for the pizza and the soda. I think he had another meeting to go to, so he couldn't be here, but he'll be back a little bit later. Other than that, I want to introduce Don. He's the speaker for tonight. So Don is the technical marketing manager at ScyllaDB, and he's going to come and present and talk about Scylla. So please give a round of applause for him.
Hi. Quick point of order. If you have a question, please feel free to raise your hand. Don't necessarily save it to the end. I'm Don Marty. I'm with Scylla. Scylla is a new implementation of the Apache Cassandra design. How many are using Apache Cassandra in production? Okay. For anything? Test? Okay. All right. Great. So Scylla is capable of more than 1 million operations per second per node, and that is using the same CQL query language that Cassandra itself supports. The latency is also lower, and this is kind of a fundamental quality of Scylla because of some of the design decisions that went into it that we'll get into a little later on. The big thing to keep in mind about Scylla is that from the server level on out, it looks like Cassandra, works like Cassandra. So any driver that you might have for Python, Go, Scala, whatever your favorite language is, that Cassandra driver is going to work out of the box with Scylla. Okay, this is actually one of the earlier benchmarks that we did. Reads, writes, and mixed. This is Cassandra version 2.19 and a pre-beta version of Scylla. And this is on a fairly beefy machine. This is a 24-core, 48 logical core system with 128 gig of RAM. So we're developing Scylla toward the requirements of newer hardware, bigger Cassandra nodes that you're going to be seeing in the near future. Latency. Anyone care to give a reason why you might be seeing unusual latency in Cassandra? Why some of these 99.9th percentile requests might be higher latency in Cassandra than in some other application? Okay. Garbage collection, there you go. All right. So as we'll see a little bit later on, Scylla has a design that's going to avoid some of the garbage collection problems that you'd see in conventional Cassandra. Okay, this is the latest benchmark. This is the pushing over 1,800 requests per second benchmark. And so all these are up on our website, and the details of how to set up your system to get a repeatable configuration to get the same class of benchmarks on your own machine is all up there. Okay, so there are fast databases out there, and then there's Cassandra, which has a lot of power in tunable consistency, resilience, big ecosystem of support. So Scylla kind of brings you the best of both. And so in addition to seeing that high performance, the data file format on disk is the same. So in Cassandra, you have an SS table data file. In Scylla, that file format is bit for bit identical. So if you have Cassandra and Scylla installed on the same host, you can bring down Cassandra, bring up Scylla on the same data files, and keep running. Now, Scylla and Cassandra will choose to split up how they write those data files in different ways. And because Scylla is designed to do as much as possible on a per core basis, you're going to get a lot of, you're going to get a larger quantity of smaller files, but they can still be read in by Cassandra. And likewise, Scylla can still read in the fewer, larger SS tables that would be generated by Cassandra. Existing drivers. Right now, Scylla does not have thrift support. If you look at the source code, you'll go through and you'll see there's some places where thrift appears, but that was kind of a bootstrapping thing. We do not have support for the older thrift-based drivers. So look for drivers that are using the new CQL query language, which is what the Cassandra scene is moving toward anyway, and those will all work. And the Python one, Java, of course, Scala, Go, they're all going to work with a Scylla cluster exactly the same way that they work for Cassandra cluster. And of course, the CQL query language. On our status page, there are a couple of odd corners of CQL syntax that we're still filling in, but our goal is to match the CQL version 3 language exactly as Cassandra does it. And when we're in GA, those alter table and a couple other little corners of CQL should be filled in. Config files format's the same. So your format that you're using for your Cassandra.yaml file, that's also going to be usable for Scylla. Some of the config file entries don't make sense in Scylla, but they can just be ignored. The management node tool or other JMX tools are going to work with Scylla. We have node tool support right now. There are other JMX-based Cassandra management tools that we're filling in support for. And you might wonder, if Scylla is not a Java application, how are we coming out and saying we've got all these JMX endpoints? Well, Scylla itself has a native REST API for management. So you can manage it over the web, use Perl, whatever. In addition to your main Scylla process, there's a separate little process called Scylla JMX. And Scylla JMX will translate Scylla's native REST management to all the JMX endpoints that you'd expect for Cassandra. So that gives you the ability to drop in Scylla and use your existing management tool. So all your application level code should work with no changes, and all the SS tables can be snapshotted and copied over, or can start Scylla on them in place. And integrations with tools like Spark. On our knowledge base, one of our developers just did an article where he found one of the Cassandra Spark integrations and did the Scylla Spark integration version of that, and that took him like a day. So integrations work, applications work, data file format's the same. So what this means you can do is you can take a large number of nodes in a Cassandra cluster, replace it with fewer Scylla nodes. All right. Any questions so far? Oh, yes.
I'm sure you covered this, but I could like curious. Okay. What's the underlying technology? Is it Java, C++? What is it?
It is one of the first major applications written from the ground up in C++ 14.
Oh, C++.
Yes.
Cool.
Yes. So, and the reason why our CTO and the team decided to go with C++ 14 is that they wanted to take a bunch of systems programming techniques that you'd see in Linux kernel code, that you might see in high performance relational databases, and take some of those heavy computer science, super fast techniques and bring them over to the NoSQL space. And so NoSQL's kind of had this idea of focusing on the scaling to large numbers of nodes, focusing on the big clusters, while the application itself within the node is more of a conventional design. And so what we're doing is taking a NoSQL cluster design and running a very fast individual node as the part that makes it. All right. How it works? Well, it gives you a pony. That's how it works. All right. So the architecture of Scylla is sharded out to individual cores. So it's almost as if a multi-core modern server is acting like a cluster in a box. So cores control their own memory. Any data that has to travel between one core and another on the same box will go through a queue. And so for each pair of cores on the system, there's a pair of queues. So they never have to lock any data structures for passing information between cores. The framework behind this is something called C*, which is a C++ 14 framework that gives a programmer a high-quality set of syntax on top of these message passing primitives. So it's organized around futures, promises, and continuations, so you can reason about it and test it in the process. And so in the process of developing Scylla, the development team was able to not go insane with the complexity of the message passing. The caching in Cassandra, what is cached in memory is the same SS table format that's being written out to disk. So Cassandra is dependent on the system page cache. Scylla handles it at a different level. So instead of caching in memory, what's being written out to the disk, the cache is completely different. And I have another slide on the cache coming up. Exploiting all the hardware resources, that's just a matter of running all the cores flat out. Nothing is ever blocked waiting for another core.
Question?
Yes.
So, it seems to be pretty high-performance application. How does it handle like a diverse landscape? So you have a lot of different nodes, like different types of nodes.
Yep.
Does it balance accordingly based on the performance of each node?
Well, in Cassandra, you can do what they call VNotes. So instead of each node being responsible for a section, for the same size section of the key space, you can configure different capacity nodes to support different numbers of virtual nodes. And so in Scylla, you would basically do the same thing. So if you had some 48-core machines and some 4-core machines, you could give some of them a lot smaller range of the data.
So it's like a manual tuning you have to do yourself.
You have to tell it how big the nodes are in relative size. And then once you've done that, they will balance out the key space among themselves. So no, yeah, the nodes don't constantly benchmark themselves and figure out how big to make the amount of data they store. But once you know this machine's about 4 times as fast as this other machine, then you can split up the range appropriately. Okay, so in your classic application, this kind of thing actually worked really, really well for the, say, Unix systems of the 1980s, where you don't have a lot of SMP, where the penalty for cache misses is not so great as it is now. The design of classic applications where the kernel can block applications from getting to the hardware works just fine on older machines. But as we get more and more multi-core, these 48-core systems that we've been testing on, even you go to Amazon EC2, you can get a mid-range machine, 16 cores. It's not unusual. As you see more and more cores, more and more of the system's time is being spent contending for locks on the hardware. So what Scylla does is breaks out everything into a separate shard for each core, and each core does its own thing. Scheduling is all done at the core level. Everything's running flat out. Memory management. Memory management is a thing that you have to tune a lot in conventional Java applications. You've got a lot of options for splitting up the memory between the OS and the JVM. In Cassandra, there's the ability to do off-heap memory allocations, which is another thing that needs to be configured. So memory setup in Cassandra can be complicated. Scylla has its own memory allocator, and like everything else, it is per core. So a core never has to block waiting on memory. In a conventional JVM application, something that's running in a thread wants memory. The red line means it has to wait for a lot to get memory from Java. And of course, Java has to wait to get memory from the kernel. Okay, this is a little bit more of that that C-star framework I mentioned. The idea that you can make an application work without those logs by passing information among one thread running per core. That sounds like really very difficult, insane systems programming, and it is, but the C-star framework makes it enough manageable for a developer that you can actually implement a meaningful size application in it. So here's an example of just doing a parallel for each. This is wrapping up in one testable chunk of C++ code, some very high performance concurrent programming. All right, the cache. Cassandra caching is really complicated, and I don't think I understand it super well yet. Has anyone configured Cassandra caching? Yeah. Okay. How many different levels of things would you say you had to tune? Counting the JVM in the middle, maybe.
So I haven't really tuned it much, other than necessarily just enabling.
Okay. 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 So the Cassandra cache depends on the Linux page cache for reading off of those SS tables on disk. So what you end up with is what they sometimes call parasitic rows. So you've got 4K pages on the system, and a Cassandra row that's being cached is likely to live in the same 4K page as a bunch of other rows that you may or may not need. However, because we're relying on the page cache in Cassandra, a lot of that cache ends up being taken up with extra rows that aren't used at the application level. What we can do on the Scylla side, where there's a single unified cache, is the representation for the data in the Scylla cache is different in memory from what it is on disk. So we only cache the actual rows of data that are needed. And the representation of the data in memory is not the SS table representation. It's a hardware optimized representation where things are laid out properly across cache lines, so your hardware can deal with it appropriately. And there is only one level of thing to tune, which is how much memory you put on the machine. There's no Java heap tuning. There's no extra configuration items for the cache. Everything lives in one big unified cache. Now, when Scylla does write to disk, that is all done with asynchronous I/O. And this is a good thing from the point of view of the application. However, it does expose which file systems are good at asynchronous I/O and which file systems are not so good at asynchronous I/O. And so far, in the benchmarking that we've done with Scylla, XFS is the file system that can handle the amount of asynchronous I/O that Scylla puts onto it. ext4 is not high enough performance in asynchronous I/O to give you the kind of performance gains you see with Scylla. So the first rule of setting up either hardware or VM to run Scylla on it is use the XFS file system on a good SSD, and it'll be super fast. If you run it on another file system, some stuff will still be fast, but you won't see these kinds of really dramatic gains. Okay, so it's fast. You can do the same load with fewer nodes, but if you're working on a project that's hard enough and important enough to need a NoSQL data store, then you may not be concerned about just coming in and saying, oh, we're going to save money on our cloud bill. So what can you really do with a NoSQL database when it's faster and has consistently lower latency? What are some real world problems that can be solved with it? And I'm in the process of trying to figure this stuff out. We released Scylla month before last at Cassandra Summit 2015. And we're now in the process of talking to people who are doing some of these challenging projects and exploring ideas of where Scylla can be something that makes a difference for you. So one area that people have turned out to be concerned about is doing some of the operations stuff at the same time that the system is under load. A lot of retail sites using Cassandra, for example, coming up on the biggest shopping season of the year. Of course, they aren't going to swap in Scylla today. But for next year, when you've got those heavy shopping days, how do you make it so that compaction, backups, any analytics you want to do, how do you make it so that that stuff can still continue to work even as load is added to the system? And yes, you can scale up your cluster, but increasing the cluster size also puts load on the nodes that are already there. When you decide to increase the size of your Cassandra cluster, there's going to be data replication traffic from node to node that actually increases the load, so things get worse before they get better when you go to scale up your cluster. So how do you take a problem like scaling a cluster up under load and make that work better? We think that Scylla, with having that extra performance overhead, the more consistent latency, will mean that when you go to do these things, your system's a lot less likely to give you trouble. It's going to be more resilient when all this operations work is going on. From a development point of view, and this last item is not really an operations thing, it's more of a development or data model thing. And that is, a lot of the time when you develop a Cassandra application, you can start with a data model that roughly makes sense, and then you end up having to denormalize or make compromises to your data model in order to get adequate performance. So with better caching, with more consistent performance qualities at the database level, we think you should be able to get by with sticking closer to your original data model, sticking closer to something that made sense to start out with. And that should mean faster time to develop, easier testing, and in the long run, less operational burden because you've got a saner data model to work with. And then you should be able to chill. So some of the use cases for Cassandra is having an analytics data center and an online transaction data center within the same Cassandra cluster. So your analytics workload can be pointed at one set of nodes while your online traffic is pointed to another set of nodes. It should be possible with faster performance to grow your cluster and avoid having to split out and add an extra data center for longer in the growth of your project. All right, so we're kind of coming at it from bottom up. We're coming at it from the point of view of here's what the hardware can really do. Here's how we can get out of its way from the software point of view and really do that asynchronous I/O, the thread per core, the take out all the locking and tweaking and just make it fast. So we can bring performance to it from the bottom up, and then once you have that, then what can you build on top? Okay. Oh yes, question.
I was wondering if you could explain a little bit better about having the analytics and transactions going on the same cluster. You mentioned like putting them at different nodes. How would that work?
You know about data centers in Cassandra?
No, actually.
Okay. Cassandra has the concept of a data center, which is a subset of nodes that would have effectively a complete set of the data. So you could have some racks full of nodes on the East Coast, some racks full of nodes on the West Coast. They are treated as separate data centers in Cassandra, and traffic is efficiently replicated across them, right? So a meteor hits one location and you're still selling toys from the other location. So that's one use for Cassandra data centers. What people who are pointing analytics tools at Cassandra have found is you can use that same data center mechanism to separate out nodes that aren't necessarily in a geographic different place, but nodes that have different performance demands on them. So you've got live users on the web clicking little stars wanting to get their results back right away. Those users would be pointed at production data center or data centers. And then you set up another data center and you don't point any of your live outside users at it. You have it connected to the same Cassandra cluster, so it will eventually get the same data. But then the only workload you point at that is possibly long-running analytics jobs. So your analytics people can clobber your cluster and make it run really slow, and they'll just make their own results slow. They won't annoy the users. So that's fairly common, and it's often a good idea. But if you can get by with a simpler setup, you might be able to do some analytics and some production work on the same nodes without bogging down if you've got fast nodes. Yes?
Can Scylla interoperate with the Apache Cassandra cluster? In other words, does it support protocols to enable you to say have set up a virtual data center of Scylla nodes?
That is in progress, and we're going to have an adapter tool that does let you do something like that for GA or shortly after GA, but Scylla does not natively support a mixed cluster with Cassandra nodes. So yeah, that is a question I get a lot. Can we have one data center of Cassandra, one data center of Scylla? It would be great, and there's going to be a thin, fast proxy thing that makes it possible to do that configuration, but the betas you can get now don't have that ability. Yes, in the back.
So initially, the first few slides you showed that you thought about what they did right and what they off and testing it.
Yep.
I guess practically speaking, like kind of like the medium world, where would your right performance be? Not just buying the biggest box.
Mm-hmm. Well, roughly it's going to be about 10x Cassandra on the same hardware, as long as you have reasonable hardware. So if you had kind of say you had a mid-range server that would do 20,000 with Cassandra, it's going to do 200,000 with Scylla. And of course, all the usual disclaimers apply. Use the same combination of hardware, run SSDs, and balance out your RAM and your number of cores. But it's going to be roughly 10x Cassandra on comparable decent hardware.
It's on your website, and it suggests that if you try it out, maybe get something that's plausible.
Yeah. Well, I run it on my laptop. It's definitely a battery hog for the laptop, so you're not going to spend all day in a cafe working on your Scylla-based site. There's a discussion that came up on the list a while ago about making Scylla more battery efficient in that mode, but it's not really a priority. I would love to have a super battery saving Scylla to make it easier to sit out at a cafe and not have to plug in, but that's a future thing.
What is the best way to get started?
Well, it's really easy to get started on Amazon. So if you go to our download page, there's a set of instructions on using it on Amazon. So you can use it there. If you have another cloud machine, if you have a regular server to stick it on. But the Amazon instructions are probably the most detailed. All right, Scylla is open source. The server itself is AGPL, and then some of our miscellaneous stuff is Apache licensed. So it's all open source. It's on GitHub. We are cranking out beta releases every few weeks. So 0.11 is the current release. There are RPM packages, there's a Docker container, there's an AMI for Amazon. Docker is really easy. However, it is still performance limited. So if you want it to run super fast and put up a benchmark, then install the RPMs on the system directly. Don't use Docker for now. It should be fast soon. All right, features that are being worked on for GA. As I mentioned before, a couple features of the CQL language are not fully filled in, so alter key space and alter table, those are in progress for GA. Authentication, authorization, encryption, that's also in progress for GA. The migration without downtime, that is a strategy where you would set up the Scylla data center and Cassandra data center as part of the same cluster, and it would seamlessly migrate the data. That is in progress for GA. Then there's some other stuff like supporting the old thrift protocol, supporting counters, which are kind of a controversial feature in the Cassandra scene. Those features are going to be post-GA. However, it is open source. Anyone who wants to jump in and if we got somebody implementing thrift or counters or stuff that we're putting off, then we'd be happy to take a look at it. Yes.
What is GA?
General availability. That's going to be beginning of next year. And this stuff is going really fast. I mean, I've worked on programming projects in Python where we're able to knock off features like this pretty quick because it's just writing Python. But for some reason, the Scylla development team is filling in really big features really fast. So somehow this C++ 14 thing seems to be a good balance between expressiveness and performance. Yes.
If one were to say try it on an existing installation, let's say in a Q environment,
yeah,
is it possible to just go back to the old to Cassandra, in other words, or will it mess all the files up?
It will not mess the files up. We test the SS table files that Scylla produces to make sure that they will go back into Cassandra. So you can take a copy of your SS tables from Cassandra, start up Scylla on them, do a bunch of transactions, and then shut down Scylla and copy the SS tables back to Cassandra, and it'll work.
Okay.
Yeah. So migration in both directions works. It's just the live migration, multi-mixed nodes within the cluster part that's still being worked out.
But compactions, does it support the same types of compactions? Or,
Scylla compactions happen at different times. So Scylla will kick off automatic compactions more often. It won't try to have multiple compactions happening at once, but Scylla will kick off a compaction cycle more often than Cassandra will. So there's some details of the implementation that are different, but the file format that you end up with is the same. Okay, and then some stuff for the future. Multi-tenancy, not just multi-tenant as in Scylla as a service, sending your credit card, get a Scylla cluster, but multi-tenancy as in making it easier for the same cluster to have different projects on it with different SLAs. So rather than standing up many different little Cassandra clusters for different projects, have a single large Scylla cluster that's able to fairly share resources among multiple projects under the same administration. So that's something for future. It's not scheduled for GA, but it is something that we'd like to be able to do. New protocols. There's a lot of diversity of NoSQL out there, and it would be great to have support for protocols used by some of the other NoSQL systems. There's some other interesting protocol stuff that came up on the list recently that that would be fun to have somebody try in open source. So check it out. And then vertical integration, tying Scylla together with more different stuff like Spark, of course. Let's see, Scylla is infrastructure. That's just could you take Scylla and use it as part of a larger system like storage? Could you take Scylla and adapt it for new memory technologies, non-volatile memory? Is it possible to put a web server within Scylla to reduce the number of layers of your web application? Maybe. I mean, it's stuff to think about. And let's see. Oh yeah, this is the details of the system that was used for the benchmarks that I put up at the beginning. This is using the tool Cassandra Stress. This is the exact CPUs, amount of RAM, 10 gig networking, and then this machine that was used for the benchmark has 4 SSDs on it. We used Linux software RAID process.
Question about this benchmark.
Yes.
So how, like on the latency benchmark, was that like time from client request to client getting the response and running on the same box? Or
that was, the client is not running on the same box for any of the benchmarks. There's a separate client system.
okay, so like those latency figures as well. Or last time?
I don't know. I can check on that.
You also mentioned, saw some of the conversation around the benchmark with a single node, which we expect like official multi-node benchmark, and more importantly, maybe like AFER's, maybe Jepsen, something along those lines to verify how, how
Yeah.
production ready the system is.
Okay. We do have a cluster benchmark on the site, and the results of the cluster benchmark per node are in line with the single node benchmark. So that's in progress. The Jepsen testing, excuse me, Jepsen testing is in progress. So as soon as that thing came out, we were all over it, and so we now have a we now have a QA person who is all over Jepsen and cranking out the Jepsen tests for Scylla. The thing that we want to make sure of before we go ahead and publish our Jepsen results is that A, we've got Jepsen set up correctly, and B, that if we do hit a problem in Jepsen, it's not our Jepsen configuration, it's something that's, did we find a bug in Scylla, can we fix it? So the Jepsen tests are passing as we get to them and understand Jepsen. And if you want, I can make sure to put you on the list to get our results when we put that up.
You also mentioned earlier, I'd be curious about the mixed workloads between OLTP and OLAP.
Yeah,
and,
yeah.
Cycling back on unified cache architecture, I've been wondering sort of like how the cache will impact. So like with OLAP query, you can potentially do sequential scans on gigs of data,
Yeah.
which gets the Linux page cache is ideal because then all the data is co-located.
Mm-hmm.
But with your unified architecture, so how is that going to impact those workloads? Have you guys done testing on that? Because operationally, I would
Yeah.
love to have both systems, reduce costs and have everything in one data center.
Yeah,
But
yeah.
realistically, we split them off because of impact on how the OLAP queries can decimate those sort of that kind of infrastructure.
Yeah, yeah, and there are I still don't think the Linux page cache is ideal, just because it's not a memory efficient representation of the data. It's just caching pages off the disk. But we definitely do need to do more benchmarking around those long sequential reads.
And I assume at that point, C-star is probably a big part of any of the throughput, in the sense that, like, if you're doing one thread per core, and I have a OLAP query that's literally blocking everything, how will the OLTP query sort of queue up and be handled that way?
Yeah, well, again, the ability to do really good async I/O is absolutely critical, and so we're stressing out every part of the system, which it looks like extreme computer science, but really it's using every piece of hardware that you pay for to the maximum.
And I assume then with the async I/O, there's no client-side guarantee for writes to disk, so I can't wait for Scylla to get back and go, I got it 100% confidence. It's more like I might have it, come back later.
It's the same guarantees that Cassandra will provide. So from the point of view of the client, we don't want to surprise you and say it's different from Cassandra. So it's this exact same guarantee that Cassandra will provide you for how safe your data is when you do this exact CQL. More questions? Yes.
In terms of multi-tenancy that you mentioned, what is the strategy for like how you're going to allocate resources for various tenants?
That is early enough in design that we don't have a full strategy yet. I think that some of our developers have ideas in their heads or their whiteboards or somewhere for how to make it work, but it hasn't been really spelled out yet. So get on the list and watch the list. Yeah.
I guess the last one is, it's kind of hard. It's you got 10x performance with nothing lost. Like there has to be a catch. Like I feel like there's a bait and switch here. Like are you guys expecting this 10x to actually make it to GA?
We are expecting the 10x to be actually greater when it gets to GA. Something I didn't really cover is that we have the ability to use DPDK for networking, completely bypass the kernel network stack. And of course that requires DPDK compatible hardware. And when we have the whole system set up with properly configured DPDK and the right hardware and everything else in the system balanced out, there's no reason why we shouldn't be putting up numbers that are substantially better. So there's a whole extra area of the performance that's open. All right, and finally, I'd like to ask for ideas. If you have something you want to talk about with the group, for what you think you could do with the super fast Cassandra compliant database, let me know, or otherwise come see me after.
Thanks, Tom, for presenting. If you don't mind, if you could just take the chairs and bring the tables and put them around, and please take your trash and put in the trash can behind you. Appreciate it. Also, please sign up for the LA holiday party on the website if you want to attend. It's really fun. Thanks again.